Hello, knowledge seekers. Welcome to Remedial Tutorial Academy. In this video, we're going to discuss something known as the absolute value of a complex number. So, a more common word other than absolute value for what we're going to discuss is modulus. So, more often than not, people call this the modulus of a complex number. So, what is it? Let me show you. So by a complex number, I mean a number which I'll call z, which is equal to, say, a plus bi. A here has a name. A is called the real part of the complex number. That's the real part. If you want to see some fancy notation, you could say the real part of z is equal to a. This is notation you often see when you study complex variables, which is the study of, complex valued functions and, the calculus associated with them. And b is called the imaginary part of the complex numbers. So this is the imaginary part, and you could denote that with some pretty cool notation. You would say I am z, and in this case, that would be b. Just some extra knowledge. Why not? I've got time. Just show you some mathematics here. So what is the modulus? So before I give you the formula, let me just draw a picture to explain it, because I think that's kind of cool. So here's the imaginary axis, and here's the real axis. So we're looking at the complex plane here. So this is the real axis, and this would be the imaginary axis. Imaginary. By the way, each complex number can basically be associated with the point. So you can think of a plus bi in some sense as point a comma b. So if you were to plot it in this complex plane, maybe it would be here, and this would be the ordered pair a comma b. You thought of it as an ordered pair, or you could think of it as the complex number a plus bi. And you could draw a line like this. And now we could find this distance. So this distance is going to be the modulus. So the notation I'm going to use for modulus, I'm going to put an absolute value symbol around it like this. That's the modulus. The modulus of a complex number is the distance between the complex number and the origin in the complex plane. And you could come up with a formula. In fact, why not? Let's go ahead and do it. So let's draw a triangle, and this would be a right triangle. So I'm going to indicate that by putting a little box here. So if this is the complex number a plus bi, which is associated with the point AB, we could think of this as b. And so this distance here, oh, sorry, I messed up. That would be a, so this would be a, so this distance here would be a, to drink more coffee, I just woke up. And this would be b. Okay, scratch that out so it's a little bit more clear. And now you could use the theorem of Pythagoras, which says that hypotenuse squared is equal to the sum of the other legs squared. So a squared plus b squared, the Pythagorean theorem. You could take the square root of both sides, and because the modulus of z is a distance, we do get a plus or minus, but we only want the plus. So we end up with the modulus of z being equal to the square root of a squared plus b squared. And that's the formula. That's the formula for the modulus of z. That's pretty much it. So it's the distance between the complex number and the origin in the complex plane. This is like super important, comes up in mathematics. You actually see this in differential equations when you study power series. Barely, but you do see it. So it does come up. It's kind of like, thrown out in front of you and you never really notice it. So a couple remarks about the modulus that I think are in order. Well, first, just a remark that I won't write down. It's that you can't really compare complex numbers. You can't say 3 plus 2i is less than 1 plus 6i. You can't really do that. There's no ordering like that in the complex number system. But you can do that with complex number with moduli. Or moduli. The first remark I have is that if the modulus of some complex number z1 is less than the modulus of another complex number z sub 2, then z1 is closer to the origin, right? Closer to the origin, right? Because we said the modulus of a complex number is the distance between that complex number and the origin in the complex plane. So if the modulus of z sub 1 is smaller than the modulus of z sub 2, then z sub 1 is closer than z sub 2 to the origin. 2, what happens if they're equal? That's pretty interesting. So if the modulus of z sub 1 is equal to the modulus of z sub 2, then they're both equal distant from the origin in the complex plane. So they lie on a circle of the same radius. Then z1 and z2 lie on the same circle with center at the origin, So that's kind of cool, kind of fun to know. Good thought, good thought process to think about, right? Because if I have another complex number, it's the same distance, you can draw a circle and they're both going to lie on that circle, right? Because they're both equal distant from that origin. Let's do a simple example of computing the modulus. I should have done that before, but this is just kind of like a random video, which I decided to make. So let's see, let's find the modulus of, say, I don't know, 2 minus 3i. Let's find the modulus of this. Solution. Find the modulus of this. We put the absolute value bars around it, 2 minus 3i. And the formula, recall the formula says that if you have the modulus of a plus bi, that's equal to the square root of a squared plus b squared. So if you want to use the formula, your b is -3 here, right? So it's going to be the square root of a is 2, so it'd be 2 squared plus -3, 2. And so that would be equal to the square root of 4 plus 9, which is the square root of 13. So pretty easy, really, really simple. It's not hard at all. If you're not convinced by this, you can think of it like this. It's 2 plus and then -3 times I, like that. So you could think of it like that. And so you see, this is your A, this is your B. So it matches up a little bit better for you. So it's more clear now, perhaps. I think the last remark I want to make, which is one about absolute value, is if you look at the formula. So my final remark in this random mathematics video on the internet is going to be the following. If you look at the absolute value of a plus bi, or the modulus of a plus bi, we know that's equal to the square root of a squared plus b squared. And keep in mind that every real number is a complex number, right? Because if b is 0, you just get a. So if b is 0, then this complex number is, real. Every real number is a complex number, but not every complex number is real, right? So if b is 0, then you just get the modulus of a, right? Because this goes away. And this is equal to the square root of a squared plus 0 squared, the square root of a squared. So you get that the modulus of a is equal to the square root of a squared. So this is the usual absolute value, right? So this is just absolute value for real numbers, right? That's the regular absolute value. So this formula, which was created for complex numbers, which we call the modulus or absolute value of a complex number, reduces to the regular absolute value that you're used to from regular mathematics when dealing with real numbers. Thank you so much for watching. I hope you enjoyed. Please comment down below what other topics you'd like for me to review. I upload new videos every day. Don't forget to subscribe and share for your friends and classmates. See you next time.